Yeah, good morning all of you. I'm going to discuss about conversion of an epsilon NFA to a DFA. Okay, so basically we have a state method where we can convert a given NFA with epsilon to a DFA. We have seen a equivalent cycle from given NFA with epsilon we can convert to an NFA. Okay, now what we can do is instead of directly converting into NFA and to 10 to DFA, we can directly convert a given NFA with epsilon to a DFA. Okay, so let's look at the procedure. So before going to that, let us discuss or review what is epsilon NFA and DFA. Okay, epsilon NFA is nothing but which will allow null transitions or epsilon moves, or without taking input from one state we can move to or we can go to any number of states on empty input. They can be directed with epsilon. Okay, epsilon is not a part of input alphabet set. Now what is DFA is from one state on taking one input going to only one transition or one state. Okay, so that is called DFA. DFA will not allow epsilon moves, whereas NFA will allow epsilon moves, that is called NFA with epsilon. Okay, now there are two ways actually. First method is now we NFA epsilon we are going to convert into NFA and then from NFA to DFA, that is two-step process. Another method is we can directly convert a given NFA to DFA, so we'll see that method here. Okay, now this is the given NFA with epsilon. What we are going to do is, first step is we are going to find closure of all the states like we have done it for when we are converting from NFA epsilon to NFA. Okay, now closure of Q naught, so we are going to do it here, closure of Q naught. Okay, so find epsilon closure of Q naught. I'll write it here. Epsilon closure, or we also call it as E closure. So now from one state without taking input from Q naught state, what are all the states it can reach? By default every state is reachable to itself, so that is Q naught, and from Q naught we have a direct path label from Q naught to Q1, so we can also reach Q1, which means from Q naught state without taking input, which we call it as epsilon closure of Q naught, is Q naught Q1. Like this we find epsilon closure of Q1 as well. Okay. E closure of Q1 is Q1 and E closure of Q2, because there is no path labeled epsilon from Q1 state, so by default its state is reachable to itself, so E closure of Q2 is also Q2. Okay, now this is first step. Now directly we construct a transition table for DFA. So how we are going to start constructing transition table for DFA is, while we are converting from NFA with epsilon to NFA, we take the initial state. In the same way, we take initial state of DFA is epsilon closure of Q naught, as Q naught is initial state, that will be a initial state of DFA. Okay, so initial state, so after calculating epsilon closure of initial state, that will serve as initial state of DFA. So here which is Q naught Q1, now Q naught Q1 becomes the initial state of DFA. Okay, so after finding initial state, what we have here is, now we construct a transition function like this, delta kappa. Okay, so Q0 Q1, input symbols are on A and on B. Okay, so now this is your initial state. Okay, now for this initial state we do transition on A, for this initial state we do transition on B. This is DFA transition table. Okay, so now how we are going to do transition here is, we write it like this, delta cap is nothing but DFA, Q0 Q1 on A. Okay, So now the only difference comes in transition, so that we are going to get equivalent by applying how we have converted from NFA epsilon to NFA, the same transition conversion we do it, which is E closure of, the formula is this, E closure of delta of E closure of Q0 Q1 on A. Okay, so which is nothing but E closure of, okay, delta of, first we solve the inner bracket. E closure of Q0 is, we have done it, which is Q0 Q1, and E closure of Q1 is, which is also Q1. Okay, so now we are not repeating here, we write it here. Now E closure of, and then we'll solve inner bracket, delta of Q0 on A union delta of Q1 on A. Okay, so what we get it here, E closure of delta of Q0 on A is E closure of Q0, and E closure of, we separate it here, Q1 on A is Q2. Now what we are going to get, E closure of Q0 is Q0 Q1, and E closure of Q2 is Q2. So now this is the state, new state that we got it on input A. So we write it here, Q0 Q1 Q2. Now for this new state you have to do transition like how we have done it for DFA, Q0 Q1 Q2. Okay, so Q0 Q1 on B should also be done, Q0 Q1 Q2 on A should be done, Q0 Q1 Q2 on B should be done. Like this we have to do transition till no new states have come. Okay, so we'll see this Q0 Q1 Q2 Q0 Q1 on B as well. Okay, so now we'll continue it here. So Q0 delta kappa Q0 Q1 on B, which is E closure of delta of E closure of Q0 Q1 on input B. We write it E closure of delta of, first we solve it inner bracket, E closure of Q0 is Q0 Q1, E closure of Q1 is Q1, so we are not writing it twice here, and B equal to E closure of delta of, we write it here, delta of Q0 on B union delta of Q1 on B. Okay, so which is E closure of delta of Q0 on B is, in the given diagram, Q0 on B it's not defined, fine. Q1 on B, Q1 on B, it's Q1 only. Okay, so we got it E closure of Q1, which is Q1 only. Now here we write down E closure of Q0 Q1 is Q1 only. Okay, now this is a new state Q1. We have to do transition for Q1 as well. Okay, so we'll do it for Q0 Q1 Q2 on input A and Q0 Q1 Q2 on input B. Okay, I'll write it here, delta kappa Q0 Q1 Q2 on input A, which is E closure of delta of E closure of Q0 Q1 Q2 on A. Okay, we got it, E closure of delta of E closure of Q0 is Q0 Q1, E closure of Q1 is Q1, E closure of Q2 is Q2. So we have solved this first one and then on A. Okay, so which is E closure of delta of Q0 on A union delta of Q1 on A union delta of Q2 on A. So which is what we are going to get it here is E closure of Q0 on A is Q0 union Q1 on A is Q2, Q2 on A is Q2. So we write it E closure of Q0. We separate the outer bracket union E closure of Q2. As we have Q2 twice, we write it once, which is we got it E closure of Q0 is Q0 Q1 and E closure of Q2 is Q2. So now we go there and update it here, which is Q0 Q1 and Q2. Okay, so now this is our new thing. Okay, now we do it delta kappa Q0 Q1 Q2 on input B, which is E closure of delta of E closure of Q0 Q1 Q2 on input B. So what we got it here is E closure of delta of E closure of Q0 is Q0 Q1, E closure of Q1 is Q1, E closure of Q2 is Q2 on B. So we write it here E closure of Q0 on B delta of Q0 on B union delta of Q1 on B union delta of Q2 on B. So what we are going to get it here is E closure of Q0 on B is 5, Q1 on B is Q2, Q2 on B is Q2. So what we got it is E closure of Q2, which is Q2. So now this is a new state Q2. For Q2 also you have to do transition. Okay, we have to do transition for Q0 Q1 Q2 Q1 and this is okay. So Q1 on B is Q1. So now here we get it here Q1 Q2 Q1 Q2. Okay, now this is your new state Q1 and Q2. Q1 Q2. Now for this Q1 Q2 we have to do transition. Okay, so when you till how long you have to do transition? Until no new state has been formed. Okay, now when we do it like this, we got a transition Q1 on A, Q1 on A it's Q2, Q1 on B is Q1. So Q1 on A we got it is Q2, Q1 on B is Q1 and Q1 Q2 we have to do transition for Q2 as well, new state. So now when we do it Q1 Q2, okay, so finally we got this. Okay, so now initial state is Q0 Q1 and what could be the final state? In the given thing NFA-epsilon Q2 is the final state. When we are constructing DFA, wherever Q2 is there, you mark it as final state. So this is your DFA for a given NFA with